Hey, thank you for that wonderful introduction. So he told you who I am, what I do, and what we do as Omni. And one of the key things that we focus on is transforming IT operation and delivering quality results. So I'm going to briefly touch on shifting left and how companies can use source analytics to take a more broader approach to drive value and business decisions, regardless if you're using CI/CD, waterfall, or agile. Now here's a question. The audience out here, what methodology are you using? Oftentimes, people say we're using agile. Some using waterfall. But in reality, it's probably a hybrid. You have something called agfall, or variations are just kind of testing in the wild or developing in the wild. But as you mentioned earlier, what is shift left? There's various definitions out there. So anyone in the audience want to take a stab at what your definition of shift left is?
Test earlier in the development cycle.
Okay. Anybody else?
Actually removing the division between developers and QA and their roles in each cycle.
Perfect. And I like how she framed that up. So in there is not one exact definition of shift to the left. It's more of a concept that can be embraced by companies to do things faster. Doing things faster don't always mean with quality. So what we're going to discuss here is doing a little bit of combination of both. Doing things faster and doing things with quality. So you have kind of the age-old proverb out there. The earlier you find a defect, the cheaper it is. However, in new methodologies out there, it's key that quality and governance is done across all areas of the software development lifecycle. And you want to do that in requirements, design, development. And if any of these are not done with quality, you will be producing defects faster and getting the instant feedback that comes along with DevOps, CI/CD. But when you do that, you have wasted time and money in that cycle if the requirements are written wrong. I don't think anybody in here have ever experienced getting wrong requirements handed to them in development. Never? So that usually happens. You get bad requirements, and then you have bad designs, and by the time you know it, it ends up in testing. So Omni has taken an approach with our clients of ensuring quality throughout all phases of the SDLC by moving quality to the left of testing in conjunction with moving testing to development and finding and removing defects early in the process. So I want to pause there a little bit, because in there, when you start looking at what I just talked about, we're talking about finding defects here in requirements, not waiting until it gets to testing. When you find it there in requirements, traditionally you talk about costs, and we'll get a little bit further into that later. Your cost is roughly, oftentimes, about 1x. Then you get in development, it's 2x. Testing 3x. When it gets to production, it can be 5x, and even further, depending on what your product does. So, when you talk shift left, what does it really do? Shift left accelerates attention to quality from the inception of the software development lifecycle. It promotes inclusion of quality assurance right from the requirement phase of the process. Quality assurance is no longer a separate task only done post-development. It is a continuous integrated process. So when we look at shift left, we're talking about doing continuous improvement, continuous integration, all at the same time. Why do companies need to shift left? So various studies out there have shown that 56% of defects originate during the requirement phase, as compared to 7% during the coding phase. In this example, you see 27% was found in design. So what does this data tell us? It tells us that groups wasted time and money because once the project or feature was delivered, it did not meet the objective of why it was being done due to bad requirements or design. So I asked that question again. Anybody in this room, you don't experience that, do you? How many times have you gone through the entire process, you deploy it, and they say, this is not what we want? And especially if you have the business units, they come back and they said, IT sucks. You guys are not delivering on what we want. And then when you start tracing it all the way back, guess what? They gave you the wrong requirements. Oh, there you go back. They gave you the wrong requirements. And oftentimes they won't take ownership that they gave you the wrong requirements. They want you to be a magician, understand what they want, and understand the end results on that. So what are some of the benefits when you shift left and embrace more than just moving testing to development? You get reduced defects, lower project costs, increased collaboration, enhanced customer experience, increased time to market, increased project execution. So basically, you're speeding things up faster. So the big question is, how do you achieve shift left benefits? At Omni, we have determined it's a combination of two known processes working together in unison to get maximum benefits. And as you see right here, the top CI squared and CD squared is really continuous integration, continuous improvement, continuous delivery, and continuous deployment. When you look at the various charts, on the left is more focused on continuous improvement. And if you look at the number one slot there, is track and monitor. If you were at the keynotes that started on yesterday, they talked a lot about metrics and what you need to do and how you need to monitor it. And so in order to start your continuous improvement, the first thing you have to do is start tracking and monitoring. So you determine in your requirements, what am I going to track to determine are they producing them correctly? One of the ways to track it is, once they put a requirement out there, how many CRs are produced on that requirement before it gets to development? And then even after it gets to development, how many CRs are made after that? Once you get to a certain level of CR, in theory, you should send it back, because most likely by the time it gets to the end of the cycle, it's not going to be what is expected. And then all the way through that entire cycle, you're going to determine the KPIs and the metrics that you want to monitor. On the left, those are some of the key things and questions that are solved by continuous delivery and continuous deployment. But what we want to talk a little bit more about here is, how can you use source analytics to begin your shift left journey? So what do you do with source analytics? Source analytics help provide visibility into your tests, platforms, and applications, so you can review tests, metrics, analyze test results, and determine the quality of your applications. So we use the test trends to analyze the defects to determine behavior over time with certain browsers, certain mobile OS, and all of the various parallel testing that is done with source. But in the test history, we analyze the root cause of the defects to see whether issues are occurring. Now, having your defects categorized properly is the single most important to our shift left methodology. So I want to repeat that. Having your defects categorized properly is the single most important driver in our shift left methodology. Why do I say that? Because oftentimes, defects are not categorized right. Usually in development, they'll use environment, they'll use data as easy, low-hanging fruits when they really don't want to point the fingers at themselves. So the first thing we do with our clients is go through and ensure that all of their defects are in the proper categories. So I don't know how many developers we have here that was former developers, but since we're going CI/CD, there's probably developers here along with testers. So how often are you categorizing your defects in the wrong category? 50% of the time? 100% of the time? It varies. So when we take and you want to drill down into the source analytics, so here's a snapshot of the analytics within Sauce Labs. It highlights the pass and fail errors from tests that was executed. And so what we do, we look at the metadata of these tests that are executed to derive even further information, such as, is there a particular OS or browser that has been encountering issues consistently over time? If so, why is that happening? Is it bad requirements being developed? Is the development team designing it wrong and not following the requirements? Or is it the data that's being fed to the test case? Whatever it is, you're constantly producing flaky tests. There's been a lot of talk around flaky tests yesterday by one of the speakers. And so I think flaky tests is a common thing that is seen when you execute parallel testing. You come back, and I even heard what they talked about. They dismiss some of the flaky tests by rerunning it again. But then, next thing they know, you find it in production, but you discounted it as a flaky test when it really was an issue. And so that's some of the things when we start driving into the metadata, we determine what that true root cause is. Did it move? Oh, let me go back. All right, so we've talked about how you marry two existing methodologies that have CI squared and CD squared. But we found that to truly shift left, you have to look at the data over time. So SOS holds runtime data for about 30 days. And the metadata is retained a little bit longer. And so here, you see the snapshot of what a test looked like over time. And so to truly do shift left, you have to have the historical data. Now, due to SOS kind of holding the data 30 days and metadata a little bit longer, so we have to extract that data and put it into a separate repository. Because a lot of our clients want to know what the trend is over 12 months, 24 months. And so in there, you'll be able to determine what are the root causes and what are the behaviors that is happening within our organization that's preventing us from truly shifting left. So the question that is asked, what can I do with all of this sauce? Because within SOS Labs, every time you run a test, it's producing metrics. And so how can I take all this sauce and affect change in my organization to drive better behavior and improve customer experience? Because at the end of the day, everything we do ends up in the customer hand. And if we don't improve that experience, over time, that customer may go to another particular product or another particular application, or even if it's a store, go to another store. And right now, everybody's hopping on Amazon. So they'll go to their native app, if it's Walmart or Target or Best Buy, and they can't find what they want and do it in one click, most likely they're gonna go to Amazon. Because within there, boom, they hit Prime, and it comes right there. So here's an example of what can be done with all of the sauce that comes within SOS Lab when you run and test. So what we have here is an application scorecard that can be produced to determine how quality is either improving or degrading over time. In this example, the SDLC is waterfall, and one of the KPIs is the defect found in the correct phase. And that is shown right here. So usually in a waterfall, you'll have system test teams. They'll get a little lazy. And what they do, they'll throw the code over the wall to end without testing it. And then here we're able to track based on what that scenario was it found in the correct phase? Because oftentimes there are defects that should be found in system tests versus end-to-end. And then when you extrapolate over to production, there's defects that end up in production that should have been found in end-to-end. So in there, we kind of measure that on an application basis. Also, you can track how well application teams are properly categorizing their root causes of defects. Many teams are measured by defects, so they will try to game the system. So if you was here yesterday and listened to one of the keynotes, and in there was how metrics shape our culture. So from there, when people start realizing how I'm being measured, they will start changing their behaviors and gaming the system. Many development organizations are measured on how many defects are found. And when you start finding too many defects, it makes that group look bad. And in there, they'll start playing with the categories and saying it's environment, it's data, but they won't point the fingers to themselves. And so with there, you have to go and start measuring that in order to change that behavior over time. Also in the keynote session yesterday around metrics, it was stated you have to measure several components, not just one component. Now, as you can see here, we're measuring defect density, turnaround, test phase, root cause, and then we give them an overall score using kind of the stoplight scenario, whether it's red, green, or yellow. This is another example of what you can do with the sauce that comes from Sauce Analytics. This shows the trends of defects in each area of the software development lifecycle. It's showing whether it's getting worse or it's getting better, and you can notice that by these indicators here. If it's flat like that, it's roughly staying the same. You still need to do work. If it's here, it's bad and it's going down, so it's worse than what it was in the previous release. If it's here, it's green. That means it's going up and it's getting better. And so from there, you'll start seeing these indicators move as you start analyzing your data over release. But the real question that leadership want to know is, what are the defects costing and how are my customers impacted? And so when you start looking here, we start determining and putting cost values on each of these categories and what is happening. And so in here you see the requirements, basically it costs $1 million. In the deployment phase, that was $500,000. So what happened there? The guy in production, he fat-fingered it, pushed it out in production, and when they did root cause on that, it was a deployment issue. And so as you can see, as it goes all the way to testing, then you see testing. Why would testing cost $1 million? Oftentimes, sometimes the testers misinterpret the requirements. Then from there, they write the test cases wrong. And from there, then you have to have a training kind of session with the testers and say exactly how you need to be writing the test cases to test that particular feature. But where it really gets interesting is the customer impact costs. Because at the end of the day, that's what executives want to know. What is this costing me? And when you see that lane across the top at $5 million, that's going to get on your VP's radar. And so in there, there's different individuals out there that will discount testing, discount the defects, but when you start bringing the pure numbers of what it's costing, then they're going to look at it a little bit different. Over time, I've been doing this 20 years as I was introduced, and one of the things I've noticed is QA has become way more important now than what it was 20 years ago. And I have a little theory around why that is. So probably about 7, 8 years ago, there was a platform that was developed that allowed people to basically complain to the world. And when a lot of people start complaining to the world, other people have that same problem. Next thing you know, you got 10 people complaining. Then you got 20, you got 30. Next thing you know, you have 1 million people and it starts trending. And that platform is called Twitter. Before, what they would do would just be push the code out to the customer and they say, oh, we'll fix it in production, they'll get over it. And so in that model a long time ago, the only way that they would know it was issues is feedback from the QA department. But now, with the rise of Twitter, they're getting instant feedback from the field. And the last thing these executives want to do is be trending on Twitter because of an issue. And so I think that has been one of the biggest benefactors to the testing space is the rise of Twitter. And so when you bring it all full circle and talk about Sauce Labs and parallel testing and browsers, it is imperative that when that application hits that customer's hand, that it is flawless. Because if it's not flawless, I think they'll start complaining on Twitter a little bit. So we've touched on a few items that can be done with all of the sauce from Sauce Analytics. There are many ways to slice that data to enable and support shift to the left. I just showed you a few examples. There are many, many ways to slice it depending on your organization and how it operates. I hope you've learned something today that around shift left. Now, one of the things that I really want you to take away from here is shift left is not just moving testing to development. Shift left should be an evolution and continuous process of improvement in order so when you do move that testing from development, it's flawless. Because if you don't do that, you're going to be wasting time and money and end up with bad customer experience. So with that being said, I'm going to open it up for questions and answers around shift left. The guy has the mic going around. You have a question here?
So I think one thing that I'd definitely be interested in is kind of having a way to quantify, kind of the business impact of the bugs, and like for like I'm kind of wondering like do you have any advice for someone trying to build that kind of information to present to the upper management folks?
So the question is, how do you quantify the impact costs?
Yeah. So kind of like the last slide had a kind of a matrix of kind of bugs being found in different phases, what their impact was, in the dollar amount. I think it'd be very good information for me to be able to provide like dollar impact of issues and stuff like that.
Yeah. So how you derive that cost is going to totally be indicative of your company. Mm-hmm. So depending on the product. So one example, during the speaker dinner the other night, was chatting with a colleague around coupons that show up and with their organization, and how if this coupon is not ranked at a certain level by Google, they lose X amount of clicks. And in there you can take those clicks and then reverse engineer to what that impact cost is. And so in there you got to go look at several different things. One is what type of application it is. And in that application, there's usually some revenue associated with that. And in there, you derive what that value is of that revenue and kind of work backwards. And you can use the number of defects. You can use kind of trends over time, how many people would have been clicking it versus not clicking it now. So there's many different ways to derive it. But each company, you have to go and grab their KPIs, because even inside of that is employee costs. And so that varies whether you got contractors, are they outsourced to India, are they in China, are they in rural Mississippi or wherever. And so a lot of variables go into that cost impact. And so I would say it's more of a finite swag when you do that, because it's hard to get a full concrete number, but you can get a trend and in the ballpark that executives will definitely want to take a look at that value.
Okay. So kind of customer impact cost would be based on kind of the revenue generating features of your product as well, and then the one about like different phases that'd be more based on like how much engineering time takes to
yeah.
recover.
So when you start looking at these areas here, these are a little bit more straightforward, because in your requirements section, you can almost go back and look at how much time and hours was spent on each of those, because usually employees are putting some type of time in tracking system, even though their salary and all that. They're still coding to certain projects. And in there, you'll be able to go back and reverse engineer that. But usually, to keep it simple, there's usually a value that is assigned to each area. So requirements, for an example, say each defect is costing $65 an hour. Design, there'll be another value, and so on and so forth. And in there, you derive that based on how many defects were found in that particular release and what that cost impact is.
Okay, cool.
Yep. Question 2 in the back.
A quick question about the requirement defects. Normally coming from the CR, right? Then how to define as a defect? Like say I change my requirement. Then from whatever test the dev, requirement changes, we normally don't call that defect. And how do you count the cost on the requirement defects? Really, how to define the requirement defects? Then next is what's the cost? How do you measure the cost on the requirement defects?
So
2 questions.
I'm not sure if I got both of those questions, but
The first, because requirement, how do you say requirement defects, right? Because requirement come from business ask you to develop some feature.
right.
How do you can say it's a defect?
Oh, how can I say it's a defect?
Yeah.
Yeah, so great question. So this is what happens when I say the requirement defect. Everything ends up in testing. So when it gets to testing, and in there, a defect is found. And so usually it's going to go through some triage process. Then from that triage, it's going to get bounced around from developers and back and forth to testers and different development teams if it's in an integrated environment. And from there, after they've gone through all that triage, they say, everything we see is working per what the design and the requirement says. Then they go all the way back, and then the business unit say, well, actually, that requirement was off. And at that point in time, in your defects system, and if you're using one of the old ones like Quality Center, you have selected your root cause as requirements. And so from there, that gives an indication back to the requirements team that I need to write better requirements, because how it got translated and came through the process and showed up in QA, it wasted everybody's time. And what was your second question?
How do you get the dollars on the requirement defects?
How do you get the dollars on it?
Yeah. And the trend, what I try to say, right, you really pretty difficult to shift left to the
Right.
requirement defects, because the requirement defect going down until QA, then you found the requirement defects, right? Like normally on the trend, like on the development side, right, on the whole life cycle, most time you shift left, the cost is pretty low. Like for example, you found a defect on design,
Right?
on dev, then go down to the QA, then go into the production.
Right?
My math is pretty simple, right? 10, 10, 10, 10.
Okay?
But requirement defects, even you say, okay, I found it earlier.
Right.
But normally it's not. It almost found it on a QA. That's the earliest you can find, right?
Right, but here's the thing on that. And so let me explain a little bit more in this shift left methodology, because really what you're doing is driving quality to the left. And so in here, you're measuring all of the things that happen before it gets to testing. And in there, you start tracking it and looking at trends. And in there, so in this example, you see this requirements. And so from there, I can even extrapolate and go further and drill down into it and notice this particular group, every time a project comes through, they have the wrong requirements. And so you can go to that business unit and say, group ABC, every time they do a particular project, they produce wrong requirements. And so in there, they drill into that group, work with them to teach them how to write better requirements where they're not producing defects. And so really that shift left and what we're talking about here in conjunction with moving testing to development is more of driving quality to the left of testing. So when it gets to testing, testing can only be testing and producing results based on coding issues, not requirements, design, data, or deployment, or environments. All of these should be green. But in most environments, they're not. You have to work over time with continuous improvement to get those to green. There's another question here. She was there.
That actually leads directly into a question I've had for a while, which is if requirements are so often the root of the problem, how does shift left solve that by shifting things into development, where if we have incorrect requirements, how do we fix the requirements before they're even coded? That's the question that I keep asking.
So that is an excellent question, and that is the whole part around what we're talking about here. Because if you don't start shifting left your quality assurance process into these phases prior to testing, exactly what you're saying, moving testing to development, you're not solving the problem. All you're doing is accelerating it very fast. And so when the industry is talking shift left now, they're only looking at it with a very narrow focus. Because if you don't go and address these areas here that are shown on this screen, your shift left testing to development is not solving anything. All you're going to be doing is producing more crap faster. That's it, not with quality.
That is exactly my question.
Hi, you mentioned Source Lab maintains the analytical information, the pass rate for 30 days, right?
Yep.
And you also mentioned other metadata they are maintaining for more than 30 days.
Yep.
So I'm wondering what type of metadata is stored, like they are retaining for more than 30 days.
Yeah, no, great question. So there actually was a track that went through kind of all of the details of the metadata. Now, the main thing that we do in there, so the way Sauce is storing that data, they're storing images and all of that. And so within that 30 days, you can go and look at those images. But for what we're doing in getting shift to the left here, we need those actual KPIs and metadata from the test. We don't need the images. I don't need to go back and rerun and see what was on the screen. All I need is that raw data that's there in the metadata layer, and really everything that's in Sauce Analytics is actually at the metadata. How many tests failed? What browser was ran? What OS? When it was ran? What bill is there? All of that information is available, and it's quite a bit of information that's in that metadata layer. Now, there was some discussions around how can you access that. So it'll get a little tricky over time on how you access it, because they're storing it, from my understanding, in their proprietary kind of database, and you won't be able to have access to it holistically. And so one of the best practices that we do is extract it as we go and put it in our own repository where we can hold it and run analytics on it over time. Next question. All right, so one more?
Just for clarification, when you say extracting the data as we go, are you talking about like directly parsing the test results as the tests run and
No.
then storing them? Okay.
No, so what I'm speaking of is after the test execution is done, you can go through the open APIs or REST APIs, however you want to call it,
Right.
and pull that data into your own native database.
Okay.
Once you have it there, then you have it forever.
Okay.
And so that's what I mean by that. Now, I'm probably could get slick and pull it on the fly real time into mine, but that probably would create a little bit of stress on the system that they don't want.
Sure. Okay. All right. Just wanted the clarification. Thank you.
All right. So if there's no other questions, you want to know how you can contact me, I'm on Twitter, WeHarris74. Also, you can find me at Omni Sourcing, and as well as my email address. And all of my information will be part of the conference, so you can go back to the replays, and all of the information is going to be distributed, and you'll be able to get in contact with me. All right? Thank you all for your time.